Hi, I'm Carlie Nieman, and this is my arc length project. So quickly starting off, my situation was that Veterans Park, which is in Walden, New Jersey, is down the street from my house, and I always love to take my dog to the park. This is my dog, her name is Bailey. And Bailey loves to play ball there, and she always likes to walk around and see all the children playing and everyone walking around. But she's 8 years old, so since she's a little bit older, she can't run or walk as fast as or as far as she used to before she gets tired. So if we're just going for a walk, she can walk for about half a mile before getting tired. So I want to know how many times I can walk around my path before Bailey gets too tired and I have to take her home. So quickly going out of this, I can show you my path. This is my path, so this is Veterans Park in Walden, New Jersey, and I chose to go along, there is a sidewalk on both this side and up here, a sidewalk, and this is also a sidewalk path, and this goes along the fences of the tennis court. Bailey likes to go by there because of the tennis balls and stuff, and then this is back on the sidewalk. This is a rough draft of my path. So this is an outline of my path, and I did some of the dimensions. There it goes. I did some of the dimensions, so I measured out using Google Maps that from this point, about a little past the soccer goal, specifically this trash can, to the edge of the sidewalk was 330 feet, and then I measured from that last point up until about where the curved sidewalk started, which was 89 feet. And then I measured from the straight edge of this sidewalk here to the straight edge, or the end of the fence of the tennis court, which was 250 feet. And then I measured the width of the field itself. That helped me kind of get some other measurements. But those are the three main measurements that I will be using later in my equation. So then I have two arcs here. I labeled this one as my arc 1 and this as my arc 2, and I'm going to use the arc length formula in order to find those. Next slide. There it is. Okay. So this is my arc 1. I used a straight line using the Google Maps, and I drew it right on there, and I found some points using the measurement. I measured this point to be 119 feet, and then from there I used the ruler on Google Maps and would go across to reach that point, and I'd measure how far that was. So this, for example, was 34 feet, and then went up and subtracted that number because the ruler carried the number. It would keep adding on to that number. So then I would subtract that number from the initial number, so this height ended up being 18. And then I did that for the continuing 3 points. Yeah. And then the other arc graph was easier to find a graph because I was able to find a graph that went through all the points and looked similar to the graph. However, this one was a little more rugged edged because this sidewalk here I wasn't able to use because this is under construction, so I had to walk around it. Yeah, so I used this graph because without this error here, it would have looked most similar to this. So I used this graph, and as you can see you can see what this very nice equation is. And then the next graph, I did the same procedure. I drew a line using the Google Maps and then would measure to each point. So I would take the ruler and I would measure to this point, which was 46 feet, and then measure how on the y coordinate where that would be, which in this case is -9. And I did that for 3 different points. And then I was able to find this graph, which looks pretty similar. It's a little bit enlarged, but it's pretty similar to the graph that I showed before. And all the points are covered in it, which was very nice as well. And I came up with this equation here. And then using, just finding the derivative of f of x, I found the derivative for each equation, because in the arc length formula you need the derivative of f of x, not f of x. So using the different f of x's in both of my arcs, I was able to find the derivative of each of them. So for arc 1, I found the derivative to be 2.46267 e to the negative fourth x squared minus 0.0404 x plus 1.1966. And then for the second arc, I did the same procedure and found that its derivative was 2.858 e to the negative 6 x to the third minus 9.00 e to the negative fourth x squared plus 0.0688 x minus 1.2513. And then using the arc length formula, I used the x-coordinate endpoints at each of my arcs, and using the derivative that I found of each of my arcs, I was able to plug it into the arc length formula, and then I found for arc 1 it wound up being 130.4711248 feet, and for arc 2 I found it being 252.2404966 feet. So basically this is how I found my solution. I used this edge, this straight edge here of 250 feet, added that to the 330 feet on this side, plus the 89 feet here for the other straight edge, added my arc 1 of 130-ish feet, and then added my arc 2 of about 252 feet, and the exact number for that was 1,051.71161 feet, which is approximately, I rounded it to 1,052 feet. And since there are 2,640 feet in half a mile, walking this path 2 times would equal about 2,104 feet. So because Bailey would get tired if we walked more than half of a mile, I'd only want to walk this path twice, because I wouldn't want her getting tired as we were walking through the path a third time. So from this I concluded that I would have to walk around this path 2 times before having to head home before Bailey gets tired. Yeah, so that's my arc length project. Thank you for listening.